that is going to provide for logical communication between the application process running on different hosts. Okay, so the application process use the logical communication provided by the transport layer to send the message to each other, free from the worry of the details of the physical infrastructure used to carry this information. So main here we are going to study some of the principle behind the transport layer. So the services like multiplexing, demultiplexing, reliable data transfer, flow control, congestion, all those things. And the protocols used are UDP and TCP, connectionless as well as connection oriented reliable protocols. Now, uh, here in this case, as I told, it provides a logical communication between the application process running on different host. Okay, on the sender side, see, one this side, this is sender. Okay, on the sender side, the transport layer converts the application layer message into a smaller chunks, adding a transport layer header to this chunk and create some transport layer segment. So then that layer will passes that segment. Okay, passes the segment to the network layer of the sending process. Okay, where the segment is encapsulated within the network layer and sent to the destination. Fine. On the receiving edge, means this is a receiver end. Okay, receiver end, the network layer is extracting the transport layer segment from the datagram and then passes that segment to the transport layer. Transport layer then receives that segment and then pass to the available application layer. Okay, it will take out the header part and it will send that. So the two protocols work on this is called TCP and UDP. Each of these protocols provides a different set of transport services to the invoking applications. Next, we will see the relationship between the, so this is the way it is going to work with respect to the case. Next, we will see the relationship between the transport layer and the network layers. Transport layer will provide process to process delivery service, whereas the network layer provides the end to end delivery service of the data. So transport protocol provides a logical communication between the process running on the different hosts, whereas the network layer protocol provides the logical communication between the host. So within the end system, the transport protocol moves the message from the application process to the network edge and vice versa. But it does not have any say about how the message has moved within the network code. The service that a transport protocol can provide are often constrained by the service model of the underlying network layer protocol. If the network layer protocol cannot provide a delay or bandwidth guarantee for the transport layer segment sent between the host, then the transport layer protocol cannot provide a delay or bandwidth guarantee for the application message sent between the process. Okay. So now the internet will go into support. As I mentioned, it's supporting two types of protocol. One is UDP, that is user datagram protocol, which provides unreliable connectionless service to the invoking application. And another one is called TCP, transmission control protocol, which provides a reliable connection oriented service to the invoking applications. So the internet network layer protocol has IP, that is internet protocol, which provides the logical communication between the host. So the IP service model is the best effort delivery service. This means that IP will make its best effort to deliver between the communicating host, but it makes no guarantee. In particular, it does not guarantee the segment delivery. It does not guarantee the orderly delivery of the segment or the integrity of the data in the segment. So the most fundamental responsibility of UDP and TCP is to extend IP delivery service between two end systems to deliver services between two processes running on the end systems. Extending host to host delivery to the process to process delivery is called transport layer, multiplexing, and demultiplexing. Next, we will see the concept of multiplexing and demultiplexing. Before that, we will see about the UDP and TCPs. UDP and TCP also provides integrity checking by including the error detection field in their segment header. UDP is an unreliable service, does not guarantee that the data sent by one process will arrive intact to the destination process. TCP, on the other hand, offers several additional mm, services to the application. First is reliable data transfer. Using the flow control, sequence number, and acknowledgement and timer, TCP ensures that the data is delivered from sending process to the receive process correctly and orderly. So thus, TCP converts IP unreliable service between the end system into a reliable data service between the processes. So TCP also provides a congestion control. TCP congestion control prevents any one TCP connection from swapping the links and the routers between communicating hosts within the excessive amount of traffic. So UDP traffic, on the other hand, it is unregulated. So an application using the UDP transport can send at any rate it pleases for the as long as it pleases. So these are some of the properties associated with these things. TCP, it's a reliable in order and it provides a congestion control, flow control as well as connection setup. So in case of UDP, it is a unreliable, unordered delivery and it will have no frill extension of best effort service. Okay. Then there will be no guarantee with respect to delay as well as bandwidth. That is about UDP. So next property, next feature is multiplexing and demultiplexing. We'll explain in the next class.